All right, the equation of time is what we want to talk about today. This video is going to be created here to correct some things that I had posted on a previous video. So when I was talking about the analemma in a previous video, I was talking about, I mistakenly thought of this analemma here as being factored by distance. But of course, I was going off of mean solar time, and I hadn't gone back to actually investigate or look at this equation of time, or how we get mean solar time from the actual movement of the sun. And in that study, in doing that, I came to realize, obviously, that this equation of time right here, this is going to be true for all places on the face of the earth. At all times. So that obviously blows this idea of distance out of the water. And so where before I figured that I was going down this path of thinking that we had an elliptical shape here for the movement of the sun, but it seems that the sun is actually moving in a figure 8 pattern from this equation of time. So this video here, I'm just going to kind of explain some of the things that I found in my study here of this equation of time. Now, the equation of time that we have here is going to coincide with our analemma here. So our picture of the analemma. So here we have our tropics, our mean distance inside to outside of our analemma. This is our 47-degree range. The equator is going to be our mean distance between these two. And we've talked about how that differs from our crossing, which happens at 9 degrees north. And that helps us with our breakdown for our analemma, because we know that our 23.5 degree range is equivalent to 9 times phi squared. And so that's a key correlation that's helped us thus far. And then further on, we can know that since this is 90 degrees from our north to our mean distance, that's going to be 90 degrees. We know that 90 degrees times pi times 2, if we multiply all that together, and then we're going to divide that by 24, that is also going to equal 23.5, this figure right here. Right, so that's also going to equal our 23.5 degree range. And so we can get all this correlation to figure out that our range right here, half of this 47-degree range is going to be equal to 1 hour, right? Because that gives us our circumference of the equator. It's going to be relative to this again. We're going to divide it by 24 to get relation to this 23.5 degree figure. So this 23.5 degree figure again is 1 hour. So now we want to figure out what is the width now. What is the width of this analemma? To further our understanding of what's happening here, so we really got to start looking at the movement. So we're going to track the sun's movement. So this analemma is a snapshot of the sun at the same time every day, and we're going to make that time of day noon. So this would be our mean time, noon period, and we're just going to call that the peak position of the sun every day. Now, when we do our measurement of time off of this, you'll see how it coincides to over here. So December 25th, this is going to be our chart right here of our position of the sun, the peak position of the sun by day. So our actual noon time frame, and this would be our mean solar noon. And so how does this differ over the course of the year? Well, December 25th is that's our crossing point. So we're going to coincide there. So our noon time on our watch is going to be the same as the noon time of the actual sun. And that's going to be right here, just after the solstice. So this happens 4 days after the solstice. Solstice happens December 21st. The crossing here is going to happen on Christmas, December 25th. So our equation of time is going to coincide there, and then we're going to get to our peak, which is going to be 14 minutes, 16 seconds slow. And then which is going to be right here, would be this point on our analemma as we're making our rotation. And then we're gonna have our equinox in March. And then just past March, we're gonna have our crossing, which is gonna happen again on April 15th. So April 15th, which we coincide here. So this is the peak position of our analemma again to April 15th. And then our next peak is our fast peak over here is gonna be May 14th, which is plus 3 minutes, 48 seconds. And then we're gonna start creeping back to our noon time frame, which is gonna happen a week, 7 days before the solstice. So we have June 13th, our crossing over, solstice June 21st, our peak when we wrap back around the other way, July 26th, which is 6 minutes, 33 seconds slow. Then we work back to the crossing again, September 1st. And then we work our way to our equinox is on the 21st of September there. So we're gonna hit that, and then we're gonna hit our peak at November 3rd, which is 16 minutes, 25 seconds. And that's our last real marker until we hit we'll have our solstice December 21st, and then our crossing again December 25th. So that's taking it through sort of the movement over the course of the year. Again, this is our tropical circle. So the sun moving on this sort of, ideally on this circular path, the actual instance that we see is this, we see this crossing. And so this is gonna be true no matter where you go. Obviously, depending on your latitude, right, the analemma is gonna be, so when you're, like we talked about in the previous video, this inclination of the analemma will have to do with your particular latitude. And so southern latitudes, the northern will look further away. So this will be higher in the sky. At angle, this would be like at equinox or at the equator. And then the northern, your northern is going to be like this because this is going to be closer to you. So that's how it's going to look in the sky. So, so the distance thing, so it seems that the distance has no bearing on the apparent sun, which is, that's going to be a key figure. But now we have to try and understand is why we have these, why this is happening. And so why do you have two crest points, which shouldn't be happening. If this is elliptical shape, it should just be an ellipse, but we don't have an elliptical shape. We have a figure eight happening here. We have a crossing over happening. And so that poses a question. And obviously when we go back to this other concept, you know, we're thinking that, you know, we're combining these two planes. So we have the plane of void, which is going to be your cut here, and your pole is over here, and your earth plane, which is your cut here, and your pole is over here. And so your cut is going to be wrapped around the pole, cut wrapped around the pole. And so the flux is happening sort of in this crossing, just like we talked about in previous videos. So this crossing of these two circuits are going to be happening at this apex point, at the midpoint of your week as these pulses go, right? 7 days of pulses out, 7 days of pulses out, both planes, and the midpoint, the crossing, the bridegroom is what we're talking about. So that bridegroom, again, it's phi to 1 either side of these planes. And so we're thinking of the joining of these planes is going to be relative to phi squared, or some exponent of it. I lost my train of thought. Where was I going with that? So, yeah, so how is that happening? Obviously, this must be the crossing where these coming together is coming up at an angle from center. And so when we think about how that's creating, again, it's a conical shape that we're having. And instead of just cutting our conical shape like this to get a sort of circular thing happening, obviously we're projecting up into another flat plane, which is our hydrogen layer up there of the atmosphere. And so that's what's creating this sort of shape. But because these two planes are coming together, you know, it's coming in on that crossing point and creating that sort of analemma shape instead. And how that's happening, you know, that's tough to wrap your head around on how exactly that's happening. But we do see the mathematical relationships to this. So now, when we're looking at this analemma, we're going to measure from, again, this would be we're going to measure from points to points. So from February 12th to May 14th, because how do you wrap your head around the width of this? So the width I'm gauging is going to be we're measuring from here to here. So this would be, say this is, well, which direction are we going here? I'm all crossed up. So our crossover would happen here, March to okay, so July. This would be July 26th would be right here. And then this would be November 3rd. So we would be measuring from July 26th to November 3rd. And then we would be measuring from February 12th, which would be this one, to May 14th. And so we're looking at what's the total range of time. How far have we strayed off of our noon time frame, our mean noon time frame from this point A to point B, or actually A to B, and from A to B, right? So from this point to this point, and this point to this point. And so those figures are right here. So our time frame from July to November was 22 minutes, 58 seconds from this point to this point. And this was a shorter amount of time. This was 18 minutes and 4 seconds on this other thing. So why is that relative? Well, if we take remember our range right here was 60 minutes, right? This is 1 hour for our mean distance. But we know that our crossing right here, like if this is phi squared, again, this is going to be 1, and then this is going to be phi. So this would be the golden mean in 1, and then golden mean plus 1 is going to equal phi squared. So that gives us our breakdown side to side of this thing. And then our relationship of phi to phi squared plus 1 is going to be 1 to the square root of 5, which is kind of crazy. But we're going to see that the golden mean is going to be relative to this. Like we actually can get the golden mean by adding this piece plus this piece and dividing by 2 to get the mean, since our relationship is 1 to the square root of 5. And so phi right here, we're going to see that if we divide this is representative, the length of this 23.5 degrees is 1 hour. So 1 hour divided by phi squared is going to be 22 minutes, 55 seconds, which we see as a difference of 3 seconds. And then how does that relate to our other period? Well, if we take 60 minutes and divide it by phi squared times the square root of phi, we're going to get 18 minutes, 1 second. So we're 3 seconds off both ways. So that seems like this is checking out to our findings of the relationship of this analemma in terms of phi. Now, I also wanted to touch on, while I'm talking about this, is our zodiac, because you're going to have, like, Aries is this point of the year right here when you're at the middle, and this would be the symbol for Aries, and Aries is the ram, but the ram's horn, like this would be your Fibonacci spiral right here out to your equator, your sort of your middle point, and then sort of mirrored to the other side would be the other side of the ram's horn. Now, the ram's horn curls in like this. And so this would be like ram's horn in your morning. So say you're thinking of how this is sort of longitude. This is how we would think of longitude, and then sort of the bow, how you straighten this is kind of how everybody wants to think of longitude. So everybody wants to associate longitude to our geometry right here of how we're measuring from our equator to north. But this is going to be a 90-degree segment. So we're just going to coincide. This is going to differ by a factor of pi divided by 2 is going to be our difference in factor of our radius right here, whether this is 3,965 miles or 6,225 miles, right? So 6,225 miles of longitude versus 3,965 straight miles of geometry. And that's the bow. So, stringing the bow. So you see this in that the Odyssey movie that's in theaters now. I went and watched it. I would recommend everybody to go watch that. It's pretty great. Yeah, we're going to string the bow right here. And so this would be sort of how you would think of longitude versus, your straight geometry. But this would be how you would see it in the morning. So when this is at a distance from center, you would kind of see this kind of shape in your morning, and then this would be your midday because this would be vertical to you. And then as nightfall goes, it's going to start looking like this side of it over here. So it's going to sort of look like this, you know what I mean? From your morning time to the peak position to the, so there's the altitude thing that's happening for your particular place. And so the story, like the Odyssey story, was pretty fantastic because, you're going from home and then you're hitting your peak position, which was going to be your Trojan War. But they use this sort of, it's funny, they use the Trojan horse. And, they're talking about Levitical law. So I was just looking at, I was looking up to see if they make any correlation between Homer, the Odyssey, and Levitical law. And they try to say that there's no connection, but there obviously is a connection because, Zeus would be sort of the center, Zeus's law. And so you're kind of going against Zeus's law. Well, Levitical law is going to tell you that, again, you've got to have the most purified thing to be sanctified and made holy at the top, at the apex of your day, on your Day of Atonement, which would be your midpoint. And so that's whatever the offering or whatever would be, this clean animal. I guess, they use the ram, I guess, is this idea. But, they use a horse in that thing. So, and most people would think of a horse as being a clean animal. I would recommend anybody to read Andrew Hoy's book, Eat Like Jesus, and understand the how to differentiate between these things. But, you're going to see an animal that is a grazing animal with eyes on the side of its head. It's going to be grazing. It's not going to have it's not an animal of prey. Like animals of prey have their, forward eyes, and they have the blood of another animal in their stomach. Whereas a grazing animal, like we think of cows and sheep, eyes on the side of their head, eating grass. Well, you would think that a horse then would be a clean animal, but it doesn't have a split hoof. And the castration process of a horse, it doesn't chew the food and then make the bolus and then spit it up and chew it again and then process it. So that sort of gastric process of a clean animal, we think of it in like the idea of sort of rainwater. So you're going to take seawater, which is laden with salt and other impurities or whatever, and you're going to evaporate that up into a cloud. And then from the cloud, it's going to come back into rainfall. But before it makes its way, all the way out, you're going to take that and you're going to process it again. So you've cleansed it through the evaporation, condensation, into the cloud, it's going to start to fall or whatever, and then you're going to process it again, and then there's a point where you're going to start taking the oxygen away from the hydrogen, and so you're going to have your ozone layer there, your O3, and then the pure hydrogen is going to make its way all the way up to the top, and that hydrogen is what's going to be the thing that's feeding the sun, and that's going to be on the other side of your anointed the helium. So you've got to get from the water, that seawater, you're going to have to, the food of that you got to get from unclean to clean and clean to holy, that's going to get sanctified, and it's going to give off its energy, is going to be this clean hydrogen. Well, they're telling you that they're following the story of Odysseus, and they're telling you that they're like, it's like you're going to try and follow, like you normally wouldn't be able to keep following that pulse, because the pulse is going to, the Day of Atonement, right? It's going to get offered up and become smoke, right? It's going to become nothing at the point that it gets consumed in the presence of the Lord there at the top. Well, you're going to follow that pulse out, and they go through the Cyclops on the Cyclops cave on the outside, and they come out the other side of the Cyclops cave, and then they're going to be down here in the land of giants, and they're going to deal with the pigs and everything. And then they're going to go through Leviathan. They got to avoid the Leviathan, and through the flower up to the middle, and then back out the other side. So just to point out that you have, like I said, you're going to have that sort of peak, which is going to be your tropical. This would be in your tropical area. And Daniel talks about this too with the goat. It would be the goat with the horn that would be spiking the ram or whatever. And then, you got unicorns and stuff with this other idea of this horse. But the horse looks like it should be a clean animal. It's not a clean animal. And that's how they're telling the story. They're getting around, Leviticus